Okay, in this problem we're going to solve problem 10 again. In this video we're going to solve problem 10 again, but this time we're going to try to use the law of cosines. Now the law of cosines is used particularly when we have two sides and their included angle, and we're trying to solve for the third side. And we don't actually have that in this particular case. Now there are three forms of the law of cosines. When you're trying to solve for side A and you know sides B and C and angle capital A. And it would look similar to the Pythagorean theorem, and so this is often called the enhanced or the generalized version of the Pythagorean theorem. The second form is when we are trying to find B and we know A and C and we know the angle capital B. Sorry, the first one should be negative or minus 2 BC times cosine of capital A. And in the first equation. The second equation would be minus 2 times AC. The third equation is when we're trying to solve for side C and we know sides A and B. Now one way of looking at this is that the law of cosines is used to solve triangles that are in side angle side and side 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 format. Now if you notice that we do not have either of those here, we have the third type, which is the side-side angle. Well, the law of sines is used for triangles in the form angle, angle, side, excuse me, or angle, side, angle. Both of those forms can be used when it's a side-side angle, which is what we have here, side-side angle. We don't have the included angle, so it would be 12, 9, and we have this angle of 30 degrees. But you have to remember that there can be 0, 1, or 2 triangles that meet the criteria, and we've seen this in the previous cases where there would be one triangle under certain situations and there would be two triangles under other situations, and there might be 0 in some cases. So this is the important thing here. We're not working with a form that is conducive to the law of cosines directly, because we don't have two sides and their included angle, and we're trying to find the opposite side of the included angle. What we're really trying to find here is side B, but I don't have side B, so I'm going to have to use the first formula because it takes into account the angle capital A. And so filling in the values, I would get something like this. 9 squared equals b squared plus 12 squared minus 2 times b times 12 times the cosine of 30 degrees. And I get 81 is equal to b squared plus 144 minus 24b square root of 3 over 2. And so when we simplify, we get b squared minus 12 square root of 3 times b plus 54. So we see that we have a quadratic, certainly not something we expect to factor. And so we enter the formula into our graphing calculator, x squared minus 12 square root of 3 times x plus 54. We zoom standard. We can't see the whole thing there, but we could widen our window a little bit. And we do see that we would have two values there that would satisfy that equation. And both of them are positive, therefore both of them are valid answers for B. And again, this is another indication that we have an ambiguous case here where there could be two. If I tried quickly to solve for those using intersections, or zeros rather, you note that I get the first one at 3.04, which fortunately isn't one of the answers. But there are two possible answers here showing we have an ambiguous case, and so there would be two values for B, and it cannot be determined from the information that's given.